All right, so again, we're talking about elimination today. So the same objectives. We're still trying to figure out one thing. 0 solutions, infinite solutions, or one solution. And if we do have one solution, what is that one solution? Okay, that's all we're trying to figure out today. Notice here that we have these two equations. Well, basically what we're going to do is we're going to do a giant addition problem. That's literally what we're going to do. We're just going to do a giant addition problem. So I'm going to take these two equations right here. And the first thing that you have to notice is that these are already lined up with x over x, y over y, and your non-variable over your non-variable. Does everybody understand that? And so the way that this is going to work is, like I said, I'm going to just make this a giant addition problem. That's all I've done so far, just making this a giant addition problem. Now, the reason we did substitution the way that we did is because we cannot solve for both variables at the same time. We have to solve for one variable and then take that answer and use it to solve the second variable. Does that make sense?
Yes, sir.
It's the same thing here. So by using the word elimination, what we're going to do is we are going to eliminate one of the variables. We're going to eliminate one of the variables, allowing us to solve for the other one, and then go back and plug it in. We're going to eliminate a variable, solve for the other one, and then go back and plug it in. Okay? Now, when I look at this giant addition problem, does anybody see a way that we can eliminate a variable? Hayden?
You can add the 4 by negative 4.
Yeah. If I have 4 of something, and I take away 4 of something, how many do I have?
0.
And 0 times any number, whether we know what it is or we don't, what is 0 times a number? 0. So by doing this, I end up with 0x, 3y plus 6y is 9y, and 11 minus 2 is 9. Can you see it okay?
I just can't see the first square.
Okay, let me scroll it up then. Maybe that'll be better. Maybe I'll close that window too. Is that better if it's that high, Addison?
Yeah.
Okay.
But, yeah, to rewrite it.
Alright, let me go back and fix that. Close this window. Yeah. Yeah, this is not gonna work out. Try it that way. We'll try it at the angle, see how that works. Alright, so let me erase this. Alright, so I'm just gonna redo what I did really quickly. Giant addition problem, 0x plus 9y equals 9. We're all okay with that. Alright, now, if I wanted to rewrite it, again, it's just going to look like this. 9y equals 9. Divide both sides by 9. And y equals 1. Okay, are we all okay with that?
Yes.
Now, what do I need to do now to solve for x, though? What do I need to do now to solve for x? Brian? Plug it back in. So does it matter which equation I pick? It doesn't. So I'm just going to pick the top one. So I'm going to have 4x plus 3 times 1 equals 11. So 4x plus 3 equals 11. Subtract 3. 4x is equal to 8. X equals 2. So my ordered pair where those two lines intersect is going to be 2, 1. Okay, fair enough. Questions on that? All right, here's what I want you to do. With the people around you, I want you to try. Actually, no, you're not ready for that yet. No offense.
Could you solve out the equation and put the two slopes and y-intercepts into your calculator?
You sure could. Sure can. All right, so let's take a look at this one now. I need to move these trash cans. These are not in a good spot. Okay. Now, if I look at this one, notice we still have our x's and our y's, but I don't have anything that I can cancel out yet. Can anybody think of what we could do to make this where we could cancel something out, just like we did on the first example? Yeah, what's up, Luke?
Add 3x and 3x.
Add? But if I add 3x and 3x, that gives me 6x. And what am I trying to do?
Try to get it.
I'm trying to eliminate one, right? So if I add 3x and 3x, it doesn't help me there. Brian, what do you think? Subtract negative 6y from 9, is that what you said? But even if I do that, I still end up with a positive 3y. Okay?
You can do minus 3x on both sides and get it the slope intercept.
But
You
that
could
would
do
be-
that. Here's what we're going to do. In order to get rid of one of these numbers, I'm going to have to convert one of them to be a negative. Since I already have a 3 and a 3, the easiest thing I can do is multiply one entire equation by a negative 1 and convert the entire equation to negatives. So here's what I mean by that. I'm going to multiply this entire equation by a negative 1. I'm going to distribute it basically. So when I rewrite it, I'm going to have my top equation, which is 3x minus 6y equals 0. And I'm going to add that to a negative 3x minus 9y equals negative 15. Does everybody see what I did there?
Yes.
Nothing too fancy, nothing too crazy. I just literally multiplied that entire second equation by a negative 1. Now that I've multiplied that by a negative 1, I can now eliminate one of my variables. Which one can I eliminate at this point? The x. I'm going to do my giant addition problem. These cancel out, giving me 0x minus 15y, which is equal to negative 15. Okay, what do I need to do now? Divide by what? Negative 15, good. Y is going to equal a positive 1. Okay, before I move on, does anybody need any explanation of how I did that? How I got Y to be 1? Yes, Andy.
It's not, I have a question.
Sure.
So, whenever you do this, is Y most of the time gonna be Y because it's gonna be, canceling out and then it will be the same on both sides? Or is it just these two?
It's just these two problems. All right, so now I've got to plug it in here. So I take that 1. Does it matter which equation I put it into? So I'm going to just pick the top one again. So I'm going to have 3x minus 6 times 1 equals 0. So 3x minus 6 equals 0. Add 6. So my ordered pair is 2, 1.
Okay, 1, 2, 1, 2.
Yeah, so it was a partner activity where you would each solve a problem, and that's how you would check them to see if they were the same thing.
Oh.
It's just an absolute coincidence based off the assignment.
Oh, so when you saw it out, A1 is the same as.
Correct. Yes, sir.
So both of the two ones are the same thing?
Yeah, so again, like this is a partner assignment, so what would have worked, Katie, is if you were partner A and I was partner B, you would solve it out, I would solve it out, and then to see if we were correct, we would have the same ordered pair.
So if we were to do this by ourselves as like homework, you want
Yep.
to do only one side.
Yep, correct.
There's no point to do
Correct.
So they're meant to be the same.
Correct. Now, we move on to these ones right here. They're not going to be 2-1. I can guarantee you they won't be 2-1. These two might be the same, but these two answers will not be 2-1. Correct. All right. Let me scroll it up a little bit, and we'll go ahead and move on to the next part. I want you to try this one, this 2A right here. Try this 2A. Just see where you're at before I move on to the next step. I'm going to scroll it up. I'm not changing the problem. You're still looking at 2A. I'm just moving it up so that the camera will pick it up a little bit better. Ben, can you see okay back there, or are you too far? Okay, just want to make sure. Bennett, Stone, JT, AJ, can y'all see okay from that far, or are you too far away?
I can see fine.
I think I'm too far away.
All right, Bennett.
No, I'm just
I'll move
kidding.
you up. I'll switch you with Evan. How's that?
I'm just kidding.
Stone.
Yeah, I'm good.
Okay. Anybody not see from where they're at? Okay. All right. If something happens, just talk to me. I'm not trying to embarrass you. Yeah,
Would I do the y? Like, would I eliminate the y?
you could. It wouldn't matter. It doesn't matter. Doesn't matter at all. Sorry, I probably should have specified that. Look for whatever one's easiest to eliminate, though. Then would be my response.
How come you can just like randomly multiply it and make it negative?
Because if you multiply everything by a negative, it's not changing the value of the problem.
Yeah. Need to explain it. I have one question.
Yeah.
When you go to do the y value, do you need to use the one of like you used to get the x?
It won't matter. It doesn't matter. You're talking about the equation, right?
Somehow, like, would you want to do the same thing? Like, would you want to?
Just substitute it in.
I'm confused. Oh, I see what I need to do.
Anybody got an answer yet? Okay, that's fine. Take your time. Take your time. Can I jump back in, or you guys still need some more time? All right, go ahead and give me your attention, please. Okay, do I have anything I can just automatically eliminate from this problem? No, but I see that right here I have a 2 and a 6, and I have a 6 and a 6, which means if I have a 6 and a 6, I can make one of those become negative, and then do my elimination. Do we agree? I'm going to go ahead and do the bottom one. I don't know why I choose the bottom, it's just the way that I do it. Probably because I'm subtracting there. So now I'm going to end up with 2x plus 6y equals a negative 16. I'm going to add that to a negative 6x minus 6y equal to a positive 24. Is everybody okay with that first step so far? Anything not making sense there? So then what I'm going to do is I'm going to literally add them together. And I'm going to end up with a negative 4x plus 0y, which is equal to a positive 8. Are we good there? Okay, next I'm just going to divide both sides by a negative 4. We're going to find that x is equal to a negative 2. Not sure if you're able to get x equal negative 2. Okay, cool. Katie, what's up?
Why would you divide it by negative 4?
Because there's an x attached to the negative 4, and I'm trying to get x by itself, so the only way to get rid of that multiplier of negative 4 is to do the inverse operation, which is to divide. Yes, Carter?
How did you get 24 down to 8?
Because I had negative 16 plus 24, which gave me 8. Does that make sense? Okay. Great questions, great questions. So now I'm going to plug in this, and it doesn't matter which equation I choose. I'm going to choose the top one just because. So we're going to put negative 4 plus 6y equals negative 16. We're going to add 4 to both sides. And we're going to end up with 6y is equal to a negative 12. Y equals a negative 2, so the ordered pair is negative 2, negative 2. Cool?
I think I completely messed it up and I still got to my answer.
Then maybe you didn't completely messed up. Maybe you just
Well,
incompletely
what I
messed up.
did is I put negative 2 for both equations and did the same thing by adding.
Cool.
I kind of had it right.
Well, you kind of had it right. There's no judgment. I'm just curious.